Hello, for today I'll be presenting a paper by the title Arctic, a dataset for Dexterous Bimanual Hand Object Manipulation, which is published in CVPR 2023. So the main contribution of this paper are as follows. So this paper presents Arctic, the first large-scale dataset of two hands that dexterously manipulate articulated object. This dataset contains a multi-view RGB image, which is paired with Akira 3D mesh. They also introduce two novel tasks of the consistent motion reconstruction, and they also propose interaction field estimation. And finally, they provide a baseline for both tasks on their own Arctic dataset. So this is the qualitative image. So first, they provide different kinds of video. So the first one is like allocentric video and egocentric video. Allocentric video is in a third person perspective, while egocentric video is in the first person perspective. So for each data set, they try to produce or reconstruct a 3D mesh of object and hand. So C represent the bimanual manipulation, which is reconstructed from a given video frame. So they also have a changing contact, which is the detailed contact information between the hand and the object during the manipulation. So finally, they also have object articulation, which means each object have different kinds of rigid body, which is connected to itself so that a person can manipulate or translate or rotate for a given task. So let's look to the motivation of this paper. So there exists no dataset with the ground truth 3D annotation for the study of physically consistent and synchronized motion of hands and articulated object. So far, we cannot find this kind of consistent data set for articulated object. So that's why they try to provide this data set and provide a baseline for two tasks. So when we look to the related work, so there's the hand object data set. So several data set capture human object interaction across the three categories. The first category is a human body with rigid object. The second is single hand with rigid object. So, and the last one is two hand with rigid objects. So the Arctic dataset stands out for its comprehensive 3D annotation and emphasis on dexterous binomial manipulation. So what makes it different is it provides dexterous binomial manipulation, which is very useful for real-world application. So we also have like estimating 3D hands and objects from RGB image. But this kind of method, they don't really use transformer-based reasoning. So, but on this Arctic dataset, this current method addressed some kind of complexities of articulated object in the hand-object interaction. We also have a human-object interaction detection. So human-object contact detection is very vital for various applications, include pose estimation and also grasp synthesis. But while this many datasets focus on specific aspects, Arctic stands out for its modeling of dense relative distance between the hands and the object. So they provide one task, which is field estimation that could predict the distance between the hands and each object. So especially this specific architecture makes it a little bit better than the previous dataset they provide. So this is the comparison. So now let's see how they try to define the Arctic dataset. So Arctic is a video dataset that contains accurate 3D annotation of hands interacting with articulated object. So it has like 2.1 million RGB image from multiple views. So they use 10 subjects and 11 unique objects for capturing videos of each image. So they also have provide some kind of dataset feature comparison. So in comparison, most existing datasets either focus on single hand grasping or have a limited view or lack comprehensive captures like a full human body or articulated object. So if we see in terms of hand pose and contact variation, so this Arctic dataset, like it shows a significant a greater hand pose diversity comparing to other hands dataset. And when we are trying to see the contact heat map, it also shows that the Arctic have a higher likelihood of palm contact due to the intricate manipulation of hands. So this is just some kind of comparison between Arctic dataset and the previous existed dataset that has been already publicly available. So as we can see here, on the articulated object, most of the existed data set, they don't really have the articulated object. So they just use some kind of blocked object for hand and object interaction. So another thing we can notice right away is the dexterous manipulation is not available on the previous dataset. Dexterous manipulation means we are trying to manipulate the object in a way that is very skillful with using hands as much as possible. So in the previous dataset, they only interact with the hand, for example, grasping, like carrying or putting on the top of each other. But on this dataset, they try to say like dexterously, which means they are trying to interact with the object in a way that requires some kind of rotation, translation, that increase the manipulation capacity of the model. So this is the two major difference that we can see from existed dataset and Arctic dataset that we have. So this is also some kind of qualitative visualization difference. So as we can see here on the left top corner, we have like hand pose variation. So the plot shows that the Arctic has a significant larger range of pose than all the existing dataset. So on the B, we can see the frequency of the frequently contacted region on the hand, which means like as we see from the image, the broader the heat map spread on the hand, and Arctic has like a higher contact diversity. So the last part is the C, which is shows the frequently contacted region on the object. So let's see how they acquire the given data set. So for acquisition of this data set, they try to use a motion capture setup, which synchronize the multi-view RGB system, capturing from different angle of like 30 fps. And they also capture the pipeline. The pipeline that uses this motion capture uses the 5-stage, which include the 3D templates. They try to also estimate the rotation axis, the capturing interaction between the video and synchronization. They also have to solve the pose problem, and they also have to compute the hand object contact. So as you can see here, they try to use one egocentric video and 8 allocentric videos for each object, which makes it much more richer and more diversified for a given task they propose. So this is the evaluation protocol which we already have seen. So now if we can look to how they split the data for training their own baseline task. So the data is split by subject, like 8 for training, 1 male for validation, and 1 female for testing to like ensure the gender balance between testing the model. So the 2 evaluation protocols are introduced, like allocentric, which is the third-person perspective, and egocentric, which is the first person, to mix the reality of settings. So for on this Arctic dataset, they try to propose 2 main tasks. The first task is to reconstruct the motion consistently, and the second one is to estimate the interaction field. So they provide some kind of matrix for consistent motion reconstruction. So the aim is to reconstruct a 3D hand and object motion from video during the manipulation phase. So the criteria for this matrix is to ensure the accurate hand-object contact and the smooth motion. They also have to somehow synchronize the movement between the contact hand and the object vertices. So for this matrix, they provide a contact deviation loss, which measures the average deviation between the predicted and the ground truth hand object that is in contact between the points. So they also provide some kind of motion deviation matrix, which evaluates the consistency of motion between the hands and the object vertices in the stable contact over a specific frame. So they also have acceleration error. It measures the reconstruction smoothness by comparing two acceleration difference between the ground truth and the predicted vertices. So apart from this, they also need to measure some kind of metrics to measure hand and object poses and their own relative translation. So for this, they provide a couple of a couple of metrics for measuring each translation and pose. So they also provide the mean per joint pose error, the average acceleration error. They also have like success rate, mean relative root pose error, and they also have like a matrix for interaction field estimation. So for the consistent motion reconstruction, which is one of the main tasks they propose for their own Arctic dataset, so they try to say, given a video, the goal is to reconstruct the 3D motion of object of the two hands and articulated object in a dexterous manipulation for every frame. So in order to achieve this task, they try to use the parametric model, which uses the Bimanual model. So the Bimanual model is utilized to represent a hand pose and shape through the parameters. So each object has a 3D model, and considering it a scan mesh and estimated rotation, they try to produce the pose of the 3D mesh and the pose of the articulated object they provide on the each video frame. So this is their baseline architecture. So for reconstructing the object, 3D object in hand, they use our ArcticNet, which process the given image, and they try to give some kind of a feature for left decoder, right decoder, and object decoder. So after getting this kind of each decoder, they try to give it to the parametric model of the hands, which produce the 3D mesh for two hands and the articulated object. So ArcticNet for single frame uses the encoder and the decoder structure, where the CNN encoder processes the given image, producing a feature which is used by the decoder to estimate different kinds of parameter for both hands and articulated image. So as you can see here from the image, given the CNN model, it extracts some kind of feature, and feature X is divided into three distinct decoders. So for the left hand, for the right hand, and for the object which is presented on the scene. So each decoder outputs some kind of a parameter, TL for the right, TR for the right decoder. And given this parameter model, the Bimanual will produce the final 3D mesh for two hands and articulated objects. So this is the baseline for ArcticNet, which is responsible for reconstructing the object and the hand pose mesh. So we can see here, they try to provide two models using LSTM, using like a recurrent neural network, and using the CNN model. So in some motion accuracy error, the LSTM is doing better, and in others, the CNN model is doing better. So for the next task, which is the interaction field estimation, they try to ask themselves, like an interaction field F from A to B, it represents the distance from every vertex in the mesh of MA. Let's say MA is the object, and to the closest vertex in the mesh to MV, which is, it can be a hand of each vertex. So the task is to estimate this interaction field for each image by determining the proximity between each hand vertex and the object. So they try to ask themselves, like, how far is the hand given the object position? Try to produce its proximity between the contact area of the hand and the given object. So for this baseline task, they try to propose the interfield, which estimates the interaction field from RGB image with two versions, which is a single frame interfield and a temporal, which is LSTM using their recurrent neural networks. So from the single frame version, it extracts feature using the CNN backbone and point net for distance estimation, while the LSTM version incorporates the temporal information to analyze the hand object motion. So this is also the baseline experimentation that compares the average distance error between the single frame model and LSTM model. So as given here, the LSTM model performs better relative to the single frame CNN architecture they propose. So they try to just compare the only two proposed model for field interaction estimation. So this is some kind of qualitative result. So A represent the consistent motion reconstruction. So given an image, they try to predict its 3D reconstruction hand and object, and they also have the ground truth for it. And on the right side, we have interaction field estimation. Given an image, they try to estimate the contact information between the hands and the given object. So they try to visualize this using the heat map. So the hotter region indicates that there is a high interaction, or there is a close proximity between the object and the hands they show here. So in conclusion, we can say Arctic is the dataset featuring two hands, like skillfully interacting with the articulated object, which means the object that can be rotated, translated for a given task. And they provide a synchronized video and 3D ground truth for hands and objects. It also contains 2.5 million RGB image from the different kinds of viewpoints. So the Arctic outlined two tasks, which I described before, consistent motion reconstruction and interaction field estimation. So finally, this paper has also provided two baseline model, which is by the title Arctic Net and Interfield, that are very useful for the future upcoming research. So that's it for today. Thank you for your time. If you have any question, I'll take it now.